All right, new section, chapter 8, iterations. All right, so again, if you're a programmer, if you program a lot before, you've seen these before. The syntax is a little bit different than what you probably experienced back in your other CS courses. Let me speak louder. Your other CS courses, but I think that it's worth seeing it in R because then what we do in the next chapter, I think 9 and 10. I mean, 7 and 8 become very, very important, you know. So just what you can do with R in terms of working with data frames and functions, okay, functions, iterations, as well as conditional statements. So with that being said, let's begin. So for loop, so it allows us to do a repetitive task based on a fixed number of trials. So this is just going to print numbers from 1 to 5. Please note that indices in R start at 1 rather than 0. Okay. Boom. 1, 2, 3, 4, 5. I can count to 100 or 500 real fast. Let me not do that. But let's go ahead and write a script. Let's do this example. So what it says, write an R script to calculate the factorial of a number. Okay. Factorial is the number times the previous number, right? Okay. Times the previous number to 1, and for the for loop to multiply it by an integer from 1 to n. So when you plug in 5 for n, it should give you 120. So let's try this out. Let's see if this makes sense. So what I'll say is I'm gonna say n we define as 5. Okay, let's start with our example. We'll do a for loop from I in 1 to 5. And then I'm going to say factorial. I already have a function called factorial. I'm gonna call it factorial new is equal to factorial new times I. The only issue here is that this is not going to work. Can anyone tell me why this shouldn't work? Because we didn't define what factorial new is before the actual actually this is going to not work for a different reason. It's going to tell me that factorial new does not exist because it's only going to exist within the scope of the for loop. So let's just run this to see the area exactly. So what we need to do is define it as 1. Okay, so what happens here is that factorial new times 1 is going to be 1 times 1, and 1 gets stored into this. So next time, in fact, you go from I is equal to, when I is equal to 2 is going to be 2 times 1, and then factorial new is going to be 2. And then it's going to take the new factorial, which is going to, the new I is going to be 3. It's going to take 3 times 2, gives you then 6, and right, that's 6, and then it's going to go all the way to 4. Which is going to be 4 times 6 is 24, then 24 times 5 is 120. All right, so it's 120. But if you want to just see my logic in terms of see what happens, I'll print it up here actually. Print factorial. Pretty sure you could have done this in a different way, but I'm actually new to do it within a for loop. So you see 1, 1, 2, 6, 24. Then finally when it's outside of it, because after the actual loop, the actual calculations, you'll see that it is 120. Okay, that's that. While loops, okay. Oh, grad school. While loops. So while loops run until a condition has been met, okay? Rather than compared to a for loops run until it reaches a specified number of iterations. In this situation, we said 5. If we were to say, I should put this as n. Sorry. If we were to say this would be like 120, it's a big number. I shouldn't do that. 10, this would be 10 factorial. Okay, and it'll do that 10 times. Whereas here with the while loop, we don't know the number of iterations. Okay. So here, this is a basic example where we have a specified number where to start from, and then it's going to say, wow, this condition has been met. Do what's inside this loop. Okay, do it inside the curly braces. We're going to intentionally count, count on or add to the count so that the next time it does this block of code, it legitimately will have a different count. So let's do it like this. Okay, so this is going to say it's 1, it was less than 5, continue. Okay, it continues. It's 2, it's less than 5, continue, because it's going to be 2 plus 1. 1 plus 1 gives you 2. 2 plus 1 gives you 3. 3 is less, goes to the beginning of the block, says 3 is less than 5, less than or equal to 5, and it continues. Right? But if I didn't have this line of code, I don't know if I'm going to run it right now. It's going to never stop. Okay, because, well, 1 is always going to it's going to always print a bunch of 1s because 1 is always going to be less than 5. So that's why we need to change it. Okay. Or if we were to say subtract 1, another infinite loop. Okay, which is what I mentioned before as infinite loop, is that every single time we take count, every single time we do a loop, we're subtracting 1. And it's never going to be greater than 5. So this is going to continue. This is an infinite loop as well. All right, let's do a complex example. Oh, that's a lot of words. All right, so here, write R script to simulate a login. This is temp while using a while loop. The script should prompt the user to enter a password and allow up to 3 attempts. This is cool. If the correct password is entered, the script will say login successful. If it's not incorrect, if the password is incorrect, the script should say try again and prompt the user to enter their password again. After 3 attempts, the script should say access denied. Okay. And so here I give you a little bit of a hint. Okay, so I know this is going to take a little bit of time. Okay, let me go ahead and start. So what I'm going to do is I'm going to specify what we know for a fact we need. We know for a fact we need the password secret, which is, let's define it as stat 331 summer. Okay, that's a horrible password. We need attempt to be, oh, I said equal, my apologies. You could use equal, but it's fine. It's gonna be blank. So that's gonna be the user's attempt. Okay, and then we need to specify the count. And I'm gonna start at 0. Okay. So from there, I'm gonna now say, okay, I wanna do a couple things. I want to make sure that the attempt is not the password, and I also want to make sure that the count is less than 3. So those are the 2 conditions that I'm gonna look at. And so we do while attempt is not equal to password. Okay, and I want both of them, so that's how we do and 2 ampersands, and count is less than 3. Count is less than 3. I'm going to find out what the user says the actual attempt is. And so in the hint, I've specified how to do this, how to read the line from the user. So it's called read line. I'm just going to copy and paste this. Copy and paste this. Store it here. That's fine. And then I'm going to go ahead and specify count is equal to count plus 1 to address the attempt that's being made. And then this is where it gets kind of interesting. So if the attempt is successful, the attempt is equal to password success. Password. We're going to say success. Login successful. Without the period, of course. Else if, combining terminologies, right? Else if, we're going to, if count is less than 3, we'll give them another try. less than 3. Give them another try. Try again. I can spell that fast. And then else access denied. Okay. Because what this is going to do, this is going to, once we're in this circumstance in which count is greater than 3, we're now in a situation where it's too many attempts, so it shouldn't work. So let's go ahead and try this out. So enter password. Okay, let's say it is statistics. Okay, not correct. Oh, it should have printed. I didn't say print, that's why. Let me exit that. Alright, should say print. Alright. Print. Print, 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 print. Print. Let's do this again. Okay, that's strange. We're gonna say statistics. Try again. We'll say stats 331. Let's actually really do it. And so then login successful. Okay. Because of time, you can play it around and you can test it out and see when it gets to access denied. But that's it for that example. Let's go repeat. Okay, so repeat allows you to continuously execute a block of code until a break statement is encountered. What's funny, the thing is 5, I guess 5 is the break statement. And so I guess I'm going to skip 5 because since we're already doing it here. But break allows you just to break the actual iterations that are being executed in the code. Okay. And so this is going to repeat this block until we have some type of breakage. Okay. So we specify the count and then we're going to repeat this, specify the count, print hello. And if count is greater than or equal to 5, once it hits there, it's going to break. Else, it's going to continue to the rest of the code. So there we go. So print it out 5 times. If I can do this 10 times, so on, it would actually print it out 10 times, of course. Okay, until count reaches that number. Again, we can make this a an infinite loop, which is not ideal. I don't even want to do this on the video because that's not what we want. All right. So here, with regards to our example, you can go ahead and try this. I'm going to do it in front of you. This is 3. So when it comes to this particular example, what are we doing here? It says write the R to accumulate the sum of the numbers using a repeat loop. Oh, accumulate the sum until it exceeds 100. Okay, that's fun. Okay, so what I would want to do is specify what the sum is. Sum. I'm gonna say sum. Yeah, I'm gonna say sums because they already have a function called sums in R. Okay, I'm gonna define that as 0. And I'm gonna say my initial number is going to be just 1. Okay. I'm gonna repeat this. Okay, I'm gonna use the repeat function. Repeat after me. Repeat this, a bunch of until the sum reaches 100. But how do I? First of all, I need to specify what the sums is going to be. And it's going to be sums plus I, right? And then once sums reaches 100, if sums is greater than 100, I'm going to break it. Break, not break. And then I need to increase my iterations. I is equal to, I'm pretty sure I plus plus should work. If it doesn't work, I embarrass myself, it's fine. Oh, it doesn't. Ah! Our I is equal, what is it? I is plus equal 1. Does that work? Let's see. Ah, it doesn't work. Are you serious? It doesn't do I plus plus? Okay. Let me stop. All right. I never printed it out. Oh, exactly. That's not good. What did I do wrong? So sums repeat if sums is greater than 0. Sums is 0. I is equal to, let's see. I knew I was going to embarrass myself. It's 100. I didn't read the question. Print sums. Okay. All right. So it reached that point at 105. Just for funsies, I want to see what happens here. What R is nice. I'm gonna keep them like this is not like Python because you have to have the indentation in R is not an issue. Okay, so it's gonna be 1. So sums is 1 plus 0. Okay, go through it. 1 plus 1 is 2. So 2 plus 1 gives you 3. Okay, fine. 3 is sums, and then I is then equal to 3. So my apologies. Sums is 3, and then I is going to be 2. Or 3, and then becomes 6. Okay, that makes sense. Then 4, because, okay, so it's 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 4 is 10, 15. Okay, that makes sense. And it adds up to then gets above 108, 100 and 105. Okay, that makes sense. Whew! That was a lot. I'll repeat. And so here is the next. Next is like continue in Python. Or it is continue in Python. And so if a certain condition happens, it says skip the next block of code. Okay, which is really important in Dijkstra's algorithm. And so here, in this situation, you can like, if I didn't have this statement here, you can kind of see what's going on, right? And that's it's printing numbers from 1 to 10, but I'm doing modulus, I modulus 2 is equal to 0. So what this modulus function does is looks at the remainder. Looks at the remainder of the division. So I'm gonna take 1 divided by 2 and see if there's a remainder. Of course, it doesn't, and it's not gonna have an issue. But 2 modulus 2 gives me 0, so it's going to not print. Okay, 3 modulus 2 is equal to 1 because the remainder is 1, so it's going to print. So it should only print out all the odd numbers. Okay, and so because the next is saying to ignore the code, so when it's an even number, this if statement's true and saying next, so then it's therefore don't print it. Okay. All right, let's do this last complex example. Hopefully I don't embarrass myself. Oh, this is very similar to the last example. I mean, the actual example. This is the same thing. Whereas instead of going from 1 to, well, let's still do it though. Instead of 1 through 10, we're doing 1 through 45. This is actually quite nice for us to see because we're going to create a vector first. Okay. I'm going to create a vector called data. and I'm gonna do 1 through 45. Okay, this is gonna be syntactically a little different with regards to for loops in R, in that it iterates over the actual vector. So we do I in data, it's gonna iterate through the entire. Let me not call it data. Let me call it data temp data. Okay, temp data. Right, and then when I do that, okay, it's the same exact logic. So it's going to be if I. So when I do I, that's going to look at each value within the actual temp data. I modulus 6 modulus. So if it's divisible by 6, then don't print. Right. Next. Is it print? Oh, it is just print. Okay, print the actual. This time we're actually just printing the number, print rather than print. Yeah, is that what we did? Print the number. Yeah. So we're gonna print I. Okay. So this iterates through the entire vector. So it's divisible by 6. You see 6 is not there, 12 is not there, 18. Yay. All right, well, that's it for this video. We're not going to do break because we already mentioned it earlier. But these are nice little iterative, or at least the next is not necessarily iterative, but these are iterative procedures within R. Okay. All right. Thank you.